Okay, let's have a crack at sac317 problem number 2. We're given the angular position of a rotor, told that after it completes 1.25 seconds, it starts spinning at a constant rate, and we want to know after that how long does it take for the rotor to complete one revolution. Okay, so all I got to do to get omega at any time during that first 1.25 seconds is to take the derivative of theta with respect to t. You would have to copy this down, but I've already got it on the same page I'm working on, so I'll just write it as, go ahead and take the derivative up here. I'll bring the 2 down, and then times the 42.0 radians per second squared times t, and then minus, I'll bring the 3 down, times 11.2 radians per second cubed, all times t has to be reduced, the power's got to be reduced by 1, so it's times t squared. So go ahead and multiply this through. We'll simplify. That's 84.0 radians per second squared times t, and then minus, that'll be 33.6 radians per second cubed times t squared. And then I need to know at 1.25 seconds what omega is. So omega at 1.25 seconds, I'll define that to be omega prime, omega special, which is 84.0 radians per second squared. You know, I think I'll call that omega constant. Omega sub c for omega constant, the constant value that it picks up at 1.25 seconds. Alright, so we got times t, which is the 1.25 seconds, and then minus 33.6 radians per second cubed times the 1.25 seconds squared. So just need to evaluate that to get what omega c is, and I find omega c is equal to 52.5 radians per second. Check out the units, make seconds here, cancel out one of the seconds there, and seconds squared there is going to cancel out 2 of these, so it becomes seconds to the 1, so both terms radians per second, and that's just what I need. Okay, then once it's spinning, how long does it take to complete one revolution? So I use one of the constant, I got a constant angular acceleration, but essentially just the definition, delta theta over delta t is equal to omega c, valid when it's a constant. Solve this for delta t. I got delta t is equal to delta theta over omega c, and now all I did there was I took delta t over there, omega c over here, and flip sides. And now I've got it. One revolution is 2 pi radians. Divide that by the 52.5 radians per second, and I get 0.1197 seconds, which to 3 sig figs rounds to delta t is equal to 0.120 seconds for my final answer.